Yeah, once again, good morning all. All of you, good morning.
Good morning, sir.
Yeah, in continuation of last class, we discussed about timestamp based protocol. For every operation, when you are going to perform, before that we need to fix the time stamp, means time period, how much time our transaction is going to use that particular operation. Once the time is over, then the transaction is released that particular lock and that object is available for other transaction. So that we are going to avoid the deadlocks which when the transactions are running concurrently. So that we can provide a very good mechanism with the help of timestamp based protocol. Here, as we discussed in the last class, with the example of how it is going to execute, and even we discussed about ordering of the timestamp protocols, means the smaller timestamp which transaction is having, that is going to execute first. The larger timestamp which is having the transaction, it is going to execute next. Then even Thomas Wright rule also we discussed about in the last class. We know the extension of timestamp protocol is nothing but Thomas Wright rule. Only for writing, when you are going to perform write operation on a transaction, he has provided one important rule that is going to provide some more advantages to our timestamp based protocol. That is, when TI attempts to write a data item on queue, if total timestamp of the TI transaction is less than write timestamp of queue. If the TI wants to write, before writing, we need to check the total timestamp of the transaction is less than of write timestamp of that particular object. If it is like that, means write timestamp is more than total timestamp. If it is like that, then we can understand and we can observe that write is an absolute of Q. An absolute value it is going to write on Q. So that if such type of write operations are going to happen, then as for the Thomas Wright rule, we can understand that that is the absolute value it is going to write. All of you clear in the last class things? That is a timestamp based protocol. It is extension of two-phase locking, very well. All of you clear about that? Hello? All of you clear about that?
Yes, sir.
Yeah. Now today we are going to understand about the validation based protocol. Here every topic is extension. We discussed about two-phase locking, strictly two-phase locking, rigorous two-phase locking, timestamp based locking, now validation. Here everything is one by one. We are adding some features on the transaction, on the schedule for implementation of concurrency with help of serializability. So this is the mechanism what we are going to discuss. Now, validation based protocol. Here, this is also very important. Along with timestamp, here in this validation based protocol, we have three important states or three important phases. The first phase is, please remember, very important. The first phase is read and execute phase. That initially any transaction, if you are going to execute, it first moves to the first phase. That is read and execution phase. Means the transaction writes only to temporary local variable. Then anything you are going to perform, that must be done in the local memory. The local memory means that mention only. If you are doing something that is in ATM, here that local ATM machine is going to do some updates. Here, total is a secondary storage, is a back database. But after completion of this last phase, that will be updated to secondary storage, as I told you earlier. The same way, Here, read and execution phase. So the reading and execution will be done at the local machine. Here, when we are going to withdraw your money from the ATM, here, the initial state means when you are inserting ATM card and it will be processed and it will be checked and something you are entering, something is displaying. All these things will be happen in your ATM machine only. It is not connected to the server. Once the transaction is completed, the data is stored into the permanent storage, means your account. Then you will receive a message, you are withdrawn this much amount from this ATM, like that you can get with the help of our trigger. Means that will be effect after completion of the transaction. But this first stage is only just a read and execution, whatever the instruction we are doing, that is in a local memory or temporary local variables. Are you clear? First step of validation based protocol? All of you clear? Hello?
Yes, sir.
Yeah. Now, once this is done, this phase is successfully done. If any failure is going to happen, now it will be stopped here only. Please remember. Means if you are entered your ATM, here it is asking, please enter your PIN number. If you are entering some PIN number, if it is wrong, then it will be stopped here only. No need to go for next step. Please. Here, all are satisfied in this first step, then it moves to the validation phase. And what is the meaning of validation? Validation is nothing but testing. Here in first phase, we are entered a visiting card. Now it will be checked and it will be issued that card is not available to bank ATM. Or like that, here it will be tell all the information. When you are entering password or PIN number of that particular ATM card, then it will be validated that user is valid user or not. Whatever the information he entered, that is valid or not. Or if you want to withdraw 20,000, but that account is having only 10,000, so that is also not a validated information.
Sir, someone is waiting, sir.
The time already 9:32. Still people are joining. Okay. Now the ATM that is going to you are missing my topic. Who that? I know the name. Please, I don't use in middle. If you are going to stop 100% or whatever the things I am explaining, I am going to this. Right. Here, if that validation phase will be done, here that is what the validation means. The phase 1 is executed successfully, then it will be entered to the phase 2. That is the validation. If that information, whatever the information provided by the user, not only ATM user, you can take anything. If they are go for the internet banking or railway reservation, everywhere the validation based protocol is there. Because when we are going to interact with the database, with financial things, if you use this transaction management system, that will be successful. So that's why here in this validation phase, transaction TI perform a validation test determines if local variables can be written without violating serialization. Exactly. Here, this is the local. First phase is related to local variable. Here, this validation phase is going to check that whatever the information is provided by this first phase, means local variable, whatever the local variable data, it is right or wrong, it is going to be tested by validation base. So once the validation base is tested successfully, then right phase will be done. So that will be updated into the second story. If the validation phase is going to fail, even if through from read and execution phase, it comes to validation phase, you have entered a wrong PIN number, then it will be abort the transaction. Abort means it never connected to the second stage. Abort. In transaction executed unsuccessfully. Here, when validation is done immediately, right phase will be. There is no verification, nothing is there. When validation phase is success, immediately write phase will be done. So these two and three phases are maybe interlinked. Here, when read and execution phase is going to through, then it will be comes to validation, it will be check and verify. Once it is success, immediately write phase is going to write means it is going to update. If TI is validated, the updates are applied to the database. Otherwise, roll back, whatever it is. There's some update will be done. That is stored in the second. The local variables, it is a global variable. So this is three steps are very important in a validation based protocol. All of you clear? These three phases? Hello? All of you clear about these three phases? Hello?
Yes.
Yes, sir.
Yeah. Now this three phases.
Yeah, sorry for the inconvenience. Just now power gone. I joined through my mobile data. So now is it audible? My voice is audible?
Yes,
Hello?
sir.
Yes, sir.
Yeah, sorry for the inconvenience because I don't know why power gone now unexpectedly. Okay. Now have you understood everyone three phases of validation based protocol? All of you understood these three phases of validation based protocol? Hello?
Yes, sir.
Yeah. Now, these three phases of concurrently executing transactions can be interleaved, already I told you, but each transaction must go through the three phases in that order. Yeah, these three are going to execute in that order only. First phase, second phase, third phase. But only one transaction executes validation or write at a time. Here, these two are going to execute at a time. Means here, 2 and 3 are executed at a time. Means once the transaction is validated, immediately it will be executed right phase. Means these two are looking like only one transaction. Here, but first phase, after first phase, then it moves to second phase. Here, once second phase is success, immediately third phase will be done. Here, this is the way the validation based protocol steps are going to work. Clear? Because after validation, no need to check anything. Directly, it has to update to the database, secondary storage. Means once you withdraw the money is came from your ATM machine, then automatically that updated information is updated into your server. Immediately, you will get the trigger will be fired there. That information is received your mobile. Are you clear? Are you clear? All of you clear?
Yes, sir. Clear.
Yeah. So that this type of validation based protocol mechanism, if you use in your transaction management system, and so that it is called, it will be provide the optimistic concurrency control when you obtain validation based protocol for your transaction management, then we can get optimistic concurrency control. Optimistic, optimistic means the concurrency control will be achieved optimistic way, so that our transactions are executing concurrently and without any data violation, without any other mechanisms, so that here our transactions are going to help a lot for this validation based protocol. Now, when we are going to observe a transaction, TI has three timestamps. Basically, here as for our discussion validation based protocol, here our transaction is having any transaction. If you take any transaction, it is having three timestamps. Here, three timestamps. Already I told you here this validation based protocol is extension of timestamp based protocol. That means the timestamp based protocol is extension of two phasing. Here it is only adding the feature, so that already timestamp is there. Along with that, we are having validation based protocol. These three phases. Are you clear? Are you clear? Hello? Hello?
Yes, sir. Clear.
Okay. Now, here along with this timestamp, we have the validation, so that now the three timestamps we have for the validation. One is first phase, which timestamp? Start of TI. For second phase, validation of TI, and the third phase, finish of TI. Means the TI means if you take any transaction, hello, 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 yeah, are you there? Yeah, here now we have three phases, right? Read and execution phase, validation phase, write phase. So for read and execution phase, we need to provide a start TI of timestamp and validation timestamp, finish timestamp. Here, what is the meaning of these three timestamps? Here, for start timestamp, it is the time required for TI started its execution. Here, when the transaction is came, here the transaction has to execute. It will be take time. How much time it will be required to execute this TI transaction? That is the started time. Now validation means your time required to validate, means test the TI is going to tested. Here, how much time it is taking? That validation is correct. That transaction is correct or not? Validation is nothing but testing. Validating the data. Whatever the information we are going to give, so that is going to test it is right or wrong. That is a validation. So that is going to require some time. That time is called as validation time. Means we have to provide on the time of preparation of your transaction with validation based protocol. Then we need to give the time for start for 5 minutes for starting. You need to provide, so that here the transaction never goes to deadlock situation, because one transaction is going to wait for another transaction until it has to execute. So that here you need to provide timestamp for every phase. Your validation phase, you can give again 5 minutes. Now finish is nothing but it will be successfully finished. Write operation is going to perform. Means update into the database. If you give 5 minutes, so like that, once the 5 minutes is over, it will be moved to here. 5 minutes over, it will be moved here. 5 minutes over, it will be moved to text transaction. So like that, we need to provide that required time. That is, you have to decide based on the transaction, based on the operation. Are you clear? Are you clear? Hello? Hello? All of you clear? Timestamps for validation based protocol. Yeah. Now, when we are going to get this timestamps for validation protocol, 100% the serializability will be determined, because here first you need to execute this, first you need to execute this, first you need to execute, because we are given the time. 100% it will be execute serialized way, and it will be get the uh, concurrency also, it will be increased, because once will be happen here fastly, there is no chance of deadlock. If there is no chance of deadlock, here multiple transactions are going to work. So that based on this validation protocol, we'll get the serializability, and as well as we'll get the concurrency mechanism also. All of you clear this? All of you clear this?
Yes, sir.
Yeah. Here validation, when if we are going to observe, here we have two cases for this validation based protocol when we are going to perform. The condition is we need to check if for all TI, if you take any transaction, that name is TI, with transaction, total transaction timestamp of TI is less than here timestamp of transaction TJ. Here this is I transaction, this is J transaction. The J transaction and I transaction, either one of the following condition holds. When you wanted to use this validation, means we are testing the transaction is validated or not, we need to check the condition, two conditions that must be satisfied. When if we are going to check timestamp of Ti is less than timestamp of Tj, then these two conditions must be performed. What is the meaning for timestamp of Ti is less than timestamp of Tj? Nothing is there. Simple, very simple. You need to execute Ti transaction first. You need to execute J transaction next. Means Tj always followed by T1. That is the meaning. Nothing is there. Are you clear? Because if you wanted to execute Ti, then it will be take this much time. Then compulsory Tj will be take this much time. Here compulsory, here Ti is required how much time? From here, Tj is required this much time to complete this transaction. Here, Ti will be required only this much time. 100% Tj time is more when it is going to start your transaction. So that the meaning is very simple. Timestamp of Ti is less than timestamp of Tj. 100%. The meaning is Ts is Tj is followed by Ti. Means Ti is executed first because it is a serial order, and Tj is going to execute next. That is the meaning. Understand? Don't confuse in other way. All of you understand? Hello?
Yes, sir.
Quickly. Yeah, please respond quickly. Right. Now, so that we when it is going to do like this, here we need to check two conditions. The first one is finish of Ti is less than start of Tj. Yes or no? Ti is going to finish when? Before starting of Tj. Correct? Here this is one. Here we are finished Ti here and Tj started here. So that here before started Tj, Ti is finished or not? Yes or no? Hello? Hello?
Yes,
Is
sir.
this my voice is audible?
Audible.
Have you understood what I am telling?
Yes, sir. Understood.
Yeah, please. Please respond. Here now finish of Ti. Yes, Ti is going to finish here. Means the timestamp is very less. If you take this is 5 minutes, and for this Tj execution 5 minutes. Means if Tj wants to execute its transaction, it has to wait 10 minutes. Here Ti wants to execute only 5 minutes as to wait. The Ti is executed within 5 minutes, and Tj is started after 5 minutes. So that anyway, the finish of Ti is less than start of Tj. Condition is true or false? Hello?
True, sir.
Yeah, this condition must be true. The two conditions are required to true for this. The second condition is start of Tj. Here, this is the start of Tj point is less than finish of Ti. If it is like this, start of Tj is here, is less than finish of Ti. Maybe Ti is not finished here. Ti is taking more time. Maybe started here. Maybe Ti is finished here. Is less than validation of Tj. Is less than validation of Tj. Here then Tj validation. Tj is started here. Ti is finished here, then Tj is started here. Here, if Tj is started means in this started position, it has to take only read operation, right? Here, every time, what is the first operation as per this? Read only. Then validation, then phase. Yes or no? Right phase. Yes or no?
Yes, sir.
Yo, okay. Now Ti is having more time. Maybe it is taken this much time. Now Tj is started here, but here until it will be validate, it will be read. Here when it comes to the validate, 100% the validation time is greater than the finish of Ti. Yes or no? Validation of Tj is, this is the validation of Tj is greater than of finish of Ti. The finish here Ti is going to finish here. Yes or no? Yes or no?
Sir, it's not clear, sir. Can you explain it once again?
Here we have how many phases for each transaction? Read, validation, write. Yes or no?
Yes, sir.
Yeah, we have timestamps also required 3 for reading, for validation, for finish. Correct?
Yes, sir.
Yeah, when we are going to take Ts of Ti is less than Ts of Tj like this. Now finish of Ti is less than start of Tj. This condition is clear?
Yes, sir. It's clear.
Yeah, now come to the second condition. For example, start of Tj. Here start of Tj is here. Correct? Hello? Start of Tj is here. Correct? This
Yes,
is
sir.
the point. Now finish of less than of finish of Ti means what they are telling is the Ti is not stopped here. Ti is extended to finish. It is taken up to this. Okay. Here this is finished before the start J, but here it is not finished before the start J of transaction. It has extended. It is taken some more time to finish of Ti. Clear?
Yes, sir.
Then the validation of Tj must be greater than how? Your validation of Tj must be greater than how means here Tj is started from here. Yes or no?
Yes, sir.
So when Tj is started, here it will be read. It will be read until Ti must be complete finish. It is reading. When you are going to perform read operation, there is no problem because we can read concurrently more than one transaction of same object. That's why there is no data inconsistency, so that we can perform. Correct?
Yes, sir.
Once Ti is going to finish its transaction, then Tj is started for validation. That's why validation is going to take more time than the finish of Ti. Clear? Because validation and Ti finish cannot be do in the same time because write it cannot be performed here. That's why here read can be performed here. That's why until Ti finish, here Tj can read the data first phase. Here once it is finished, then it moves to the second phase. That is a validation. That's why validation is having more time. Now clear?
Clear, sir.
Yeah, these are the two conditions must be satisfied when we are going to implement a validation test for the transaction Tj. That is what the justification here. This is the theory. What I told you. The write of Tj do not affect reads of Ti since they occur after Ti has finished its read. This is the first case what I told you. The second one, the write of Ti do not affect reads of Tj since Tj does not read any item written by Ti. This is the way you can understand this diagram also. If possible, you can draw because no textbooks and no one will be explained in this way. Please, is it clear now?
Clear, sir.
Is this clear? Yeah. Now coming to the schedule for the validation, how the schedule will be prepared for this validation based protocol for our transaction. If you take T14 read B, then T15 read B, B equal B minus 50, read A equal A plus 50. Here up to this we are not validated, means we are not updated to the secondary storage because we are not applied any write operation. Yes or no? Your write
Yes, sir.
operation you must be apply after the validation. Already I told you here. Here, read, validation, write. Once validation is done, immediately you move to the write. The same way, here, if you observe your schedule of your validation based protocol, your read, not a problem. Read, something you are doing, but we are not updated. Your read, A equal A, something you are doing, but you are not updated. Your read again A, then you validate it. Here, before this, if you write display, you cannot get updated information. You can get old values of A and B. But after validation, validation means it will be stored into the secondary storage. Here, until validate, this data is going to store into the local storage only. If you or display before validation, the only original values are display. There is no updated values are not going to display. Once you validate when you want to display, the data come from the secondary storage. We can get updated value. Here, once you can validate, we can apply write operations. Those things are going to update into the secondary storage. So this is what exactly the validation based protocol schedule. Clear?
Clear, sir.
Hello? Yeah. Right. Next one is a multiple granularity. Here, what is the meaning of multiple granularity? Here, it is extension of validation based protocol. Here, granularity is nothing but granules. Granules is nothing but parts, subparts. Here, generally, if we are going to observe nowadays, we have large volumes of data. Here, that large volumes of data, it is not possible to execute, so that we need to divide the data into fragments. Here, that is a granules. Here now, when comes to the real world, data is huge. So that generally, if whatever you are using this, it is not possible for the real-time application. So that we need to divide the data into multiple fragments. Here, that fragments generally it is called as granules. Here, granularity. Here, so that here data we are divided and we are going to use those data in a tree structure that is a hierarchy structure, okay, with help of multiple granularity mechanism. For that, we need to apply some locks on the granularity. Granules means part of the data, the fragmenting of the data. Understand? All of you understand?
Yes, sir.
Hello? The small granularities, okay, within larger ones. Here, how it is must be a tree. Already I told you hierarchy structure. You know, tree preparation in a data structure in that way only. Here, when we are going to prepare that multiple granularity in a hierarchy order, we have locking mechanism. That is a multi granularity of locking. Here, two types of locking mechanisms are required for multiple granularity. Please remember these words are very important. Fine granularity, coarse granularity. Here, what is the meaning of fine granularity? Always we are going to apply this fine granularity in a lower level of a tree. Here, why lower level of a tree? Means, for example, if you take this, here, what is the lower level? This is the lower level. Here, we need to apply fine granularity. Are you clear?
Yes, sir.
Are you clear? Hello?
Yes, sir.
Hello?
Clear.
Yeah, fine granularity you need to apply lower level, means leaf nodes to a fine granularity. When we are going to apply fine granularity of locking, there is more concurrency because more here, if you observe any tree, the lower level we have more data parts, more granularities. Yes or no? Go to the upper, it is less. come to the down, there is a more concurrency, there is a more granules. So that fine granularity is high concurrency and a high locking overhead because we need more locks because we are going to apply fine granularity in a lower level of tree. Understand? Understand?
Yes, sir.
If you take any tree like this only, correct? Yes or no? Come to the bottom, more number of leaf nodes are there. Yes or no?
Yes, sir.
Already you people are aware with data structures. Okay. Right. Now coming to the coarse granularity. Here this is higher in a tree. Here low locking overhead, low concurrency. Here comes to the up, you can apply here or here. That is a coarse granularity. Here come to the up, there is no more granules, very less granules, so that there is no overhead, very less locking things are required, so that our job is very easy. Now understand here to whom we have to apply fine granularity, to whom we are going to apply coarse granularity. All of you?
Yes, sir.
Yeah. So, say this example we can use, you can tell top level area database. This is a database, so this is A1, A2 object fragments, and this is the records. If you take database and these are A1, A2 is the maybe the tables, and F means files, R means record. Like that we can take. Okay, right. Now in this multiple granularity, please respond quickly. Time is very less. Even my battery backup also only 26 minutes. We need to finish it. Here in this multiple granularity, we have locking modes, intention locking modes, because we have already shade lock and exclusive lock. Yes or no? Already you people are aware of what is shade lock, what is exclusive lock. Yes or no?
Yes,
Hello?
sir.
Yes, sir.
Along with shade and exclusive lock, you know where we need to apply shade lock. Here, when you are going to apply exclusive lock, you know already. Along with that shade and exclusive lock, we have intention locks in a multiple granularity. Here, that is three intentional locks are there. The first one is intention shade. Intention shade means it indicates explicit. Here, intention shade means shade mechanism is a shade means when you are going to perform read operation, we can share the lock for multiple transactions so that there is no any data inconsistency. That is what exactly the shade meaning. Already you know. Here in that way, here intentionally, here shade and exclusive original locks are, you know, automatically we are going to apply when data is going to read, then you can use shade lock. When data you want to write, you have to use automatically it will come exclusive lock. Yes, that is, you know, these two are automatic locks. Yes or no? Hello? Yes or no? These
Yes, sir.
shade and exclusive locks are automatic. When you wanted to read, apply shade lock automatically. When you wanted to write, automatically exclusive lock will come. But along with these two locks, we need three more locks for this multiple granularities, that is intentional lock. Here, intentionally, we need to apply when you want to perform any operation on this multiple granularity. In such a way, we have three locks: intention shade, intention exclusive, shade, and intention exclusive. Yeah, these are intentionally we need to apply on that along with the automatic locks. Clear? Clear?
Yes, sir.
Yeah. Now the first one is intention shade. Intentionally we have to apply lock which is shade. Means here when you want to perform read operation, here intentionally you want to apply any lock, you can use intentional shade lock. Means it indicates explicit locking at a lower level of the tree. Your lower level means these are the fine granularity, lower level. Here when you want to go to the fine granularity level, then we need to apply intention shade when you want to apply any data you want to read the lower level of tree, but only with shade loss. Here only with shade lock. You can apply this intention shade lock with shade lock. It is not a problem. Intentionally you want to read in a lower level. Clear? Your explicitly, you need to apply. Okay, please. Intention exclusive. Here, when you want to write, already I told you, when you want to write means, exclusive lock, how we are going to use. In the same way, here indicates explicitly locking at a lower level. This is also at the lower level with exclusive or shade lock. So this is only with shade lock you can apply this intention shade lock. This intention exclusive you can apply along with shade as well as exclusive lock. Here, along with that you can apply intention exclusive lock in the lower level. Here all the two locks must be at the lower level. Nothing but where it is in a fine granularity level only you can apply. Clear? Clear? Hello?
Yes, sir.
The third lock is shade and intention exclusive. They're very important. This shade and intention exclusive. So this is the subtree rooted by that node is locked explicitly in shade mode, and explicit locking is being done at lower level with exclusive mode locks. Means here if you are going to apply this subtree, means subtree, if you take one part of the tree rooted by the node is locked especially in a shade mode, and explicit locking is being node at lower level with exclusive mode locks. Means here when you wanted to already it is with the shade mode, shade lock, this parent node of RC1 and RCM, which is a shade mode, then you can apply these two locks are with shade and intention exclusive. Means the parent node must be already which is applied with shade node, then only we can apply these two nodes as a shade and intention exclusive lock. Clear?
Clear, sir.
Yeah. Now intentional lock allows a higher level node to be locked in S or S means shade lock or exclusive mode without having to check all descendant nodes. Exactly. Here, when we are going to apply intention locks, allow a higher level. If you are applied intention locks in a higher level, top level, then the nodes are directly you can apply shade and exclusive mode without checking any order. If you are applied intention lock is higher level, automatically you can apply shade and exclusive lock without any checking. But maximum cases we need to apply intention lock in a fine granularity only. So this is what automatic lock, shade and exclusive lock we verified. In the same way, intentional lock also we are checking the compatibility mode, how it will be helpful. Now coming to here, if you fix a transaction, if you take any transaction T1, if you take T2, if you are already applied with object Q. So now I applied intention shade lock with T1 object Q as a intention lock. Then we can apply T2 also intention lock on object Q. So this is the way you can read. Understand? Hello?
Yes, sir.
The same object, T1 transaction wanted to do some action, T2 wanted to do some action. If T1 already applied intention shade lock on Q, even T2 also can apply intention shade lock. Is there any data loss? Clear? Like a truth table. Clear?
Yes, sir.
Hello? Now intention lock is there on Q. Here there is a chance of intention exclusive lock also possible. Intention shade is there, shade is there. Here shade intention exclusive is there, intention shade is there. Here except exclusive remaining all of the internal shade is not sharing. you can share to anyone. Here, with if you are going to share others also, we can. There everywhere share is there. But only exclusive, the meaning exclusively. Here only write operation. When it is going to write someone, that intention shared, it is not sharing is not possible. Someone is writing doing something, we cannot update it immediately. Here after writing completes only we can do the intention shared. That is the meaning. Clear? Clear?
Yes, sir.
Yeah, the intentional exclusive, if you are going to apply T1 on Q object, then T2 it is going to apply intention shared, no problem. Intentional exclusive also not a problem, but share is not. This is share, automatic share is not possible, and even shared intentional exclusive also not possible. Exclusive also not possible. Exclusive is not possible to anyone. Already we know this. It is very clear about this. Very keen. Like that, shared is possible for share, internal exclusive is not possible, share is possible, shared is not possible, not possible. Share X is, exclusive is not possible for anything, any combination. Shared intentional exclusive is possible only with intentional share, remaining all are not possible. Because this is what exactly the compatibility matrix for the intention law. Clear? Clear.
Yes, sir.
This table you need to remember. Clear? Hello?
Yes, sir. Clear.
Yeah, the last screen in the today's class, the multiple granularity locking scheme. Here, what is the multiple granularity locking scheme? Here, when we are going to perform this multiple granularity, here these are the rules. 6 rules are there. You must be observe these rules, 6 rules. Then you can understand more for the multiple granularity. One by one, I will read and I will explain. Please understand. If any doubt is there, please ask me. The first rule. The log compatibility matrix must be observed. When you want to perform multiple granularity, this log compatibility you must be observed, you must be monitored. Based on this log compatibility matrix, only we need to apply multiple granularity log based mechanism only. Clear? The first rule? All of you clear?
Clear, sir.
The second rule is the root of the tree must be locked first. Always you must be locked the root of the tree. Compulsory. Then if you apply a lock or root of the tree, then only we go with the its chunk node for reading or writing whatever you want to do. So that here the root of the tree must be locked first and may be locked in any mode. So that is up to you. If you want to lock this root of the tree, shade lock or exclusive lock, whatever the mode or intentional exclusive or intentional shade or whatever the mode you want to apply, you apply. But you must be locked first root of the tree in a multiple granularity. Clear? Hello? Are you clear about second? Yeah. Now coming to the third, because these rules are very important for multiple granularity. Please remember, otherwise note it down. A node Q is a data object. Node, you can don't feel node is something data object. A node Q can be locked by Ti in shade lock. For example, a Q object is locked by Ti transaction with a shade lock or intentional shade mode only if the parent of Q may be like this. Now this is locked with shade or intentional shade. The parent of Q is currently locked by Ti. Here, this is locked by Ti. Even this is also locked by Ti. In either locked by Ti in either IX or IS mode. Here compulsory if Ti is locking Q with shade or intention lock, its parent must be locked by intentional, exclusive or intentional shade. Then only its child must be locked by shade or intentional shade. Understand? All of you understand? If you want to lock, if you wanted to lock a child node with shade or intentional shade, that parent node of that node must be locked with intentional exclusive or intentional shade. Clear?
Yes, sir.
Yeah. Now coming to the fourth rule. A node Q can be locked by Ti in exclusive. The Ti can be locked by exclusive or shared intentional exclusive or intentional exclusive. Everywhere exclusive is there. Maybe automatic exclusive or shared intentional exclusive or intentional exclusive mode only if the parent of Q is currently locked by Ti in either IX or SIX. Means that parent node P must be locked by. Okay, please note it down this example. Okay, if you are going to confuse, then it will be help. Here this parent node must be intentional exclusive or shared intentional exclusive must be there. Then only we can apply, you can lock TI Q node with exclusive or shared intentional exclusive or intentional exclusive. Clear? Fourth
Yes,
rule
sir.
is clear? Yeah. Now coming to the fifth one. TI can lock a node only if it has not previously unlocked any node. Sir, already I told you, this is a common rule. Any transaction wants to lock any node. Sir, previously any transaction is occupied that node, that must be unlocked. So that only TI can be locked. Understand? For example, already T2 is locked with this node. If Ti wants to lock this node, here before that T2 must be unlocked this node, then only Ti is going to lock this Q node. The TI can lock a node only if it has not previously unlocked any node. If any node is already locked, you need that node has that tree has that transaction has to unlock. So that only TI can be locked. Clear? If the rule is clear,
Yes, sir. Clear.
so that is why it is a two-phase. Okay, next one is sixth one. TI can unlock a node Q. For example, if TI is going to unlock this node Q, only if none of the children of Q are currently locked by Ti. Means if, yeah, the Q children is R, the Ti also locked by this R. The Ti is locked Q and Ti is locked R. If you wanted to unlock this Q object by Ti, here before that you need to unlock this child object also. After unlocking of child object, then you can unlock the its parent object. So this is what sixth rule. Clear?
Yes, sir.
So these are the six rules must be followed when you want to implement a multiple granularity locking scheme. Clear? Clear?
Clear, sir.
Yeah. Here, as per the observation, here all of you noted down, the locks are acquired in root to leaf order. Here, don't go from leaf to root. The locks must be applied root to leaf, the top to bottom, whereas they are released in leaf to root node. When you want to release, here that must be from leaf to root. Here, achieving of the locks from root to leaf only, then releasing the lock from leaf to root. So this is the note, you must be remember this point. When you want to apply lock, any chain node, you must be apply lock on its parent node. When you want to remove or unlock the parent node, then you must unlock the its chain node. So this is the order you must follow when you are going to implement a multiple granularity locking schemes or protocols in a transaction management system. All of you clear?
Yes,
All
sir.
of you clear this? All of you clear this validation based protocol and multiple granularities. So today's session very important. All of you clear? Multiple granularities and validation based protocols.
Clear, sir.
Hello? Yeah. Please.